In this video, we're going to go over exponential graphs, the simplest of which is y equals 2 to the power of x. So we'll start by working out some sort of starting point. Okay, the easiest thing being to look at what happens when x equals 0. Now hopefully we remember that any non-zero number to the power of 0 gives you 1, which means when x equals 0, y equals 1, and that corresponds to a y-intercept of 1 right here. So how do we move from here? Well, the relationship 2 to the power of x means every time x increases by 1, we're multiplying an extra copy of 2. In other words, we're doubling the y value for each step across. So we can picture exactly that. Those y values are doubling for each step we move across, and you can already see it's going to shoot up rather quickly. Going back the other way to the left then, we'd be doing this in reverse, so the y values halve for each step we move across to the left. And that gives us a graph that looks like this. Now, of course, it extends infinitely in both directions, but as we go further to the right, it very quickly shoots to extremely large numbers. You might even hear references to exponential growth in popular culture, especially in recent times, and as we go further to the left, it quickly shoots to 0, even if it doesn't quite touch it, because halving something over and over and over again won't ever actually take you to exactly 0. But still, it's always getting closer to 0 as x travels in that direction. And more precisely, it's getting closer and closer to this red line, y equals 0, which happens to be the x-axis in this case, as x goes more and more in that negative direction. We call such a line an asymptote for the graph. Okay, again, that's whenever our graph gets closer and closer to the line like that. Now, in this case, the graph never touches the asymptote, but that's not a requirement, okay? Plenty of graphs will cross over the asymptote, and some do so even infinitely many times, right? And that's not a problem. The only requirement is that the graph gets and stays increasingly close to the line as x travels in some direction. Now, I know we're still not being overly precise or clear with what we mean here, but in order to get precise, we'd have to explore the idea of a limit, which I might do in a future series on calculus or something, but enough on that for now. Okay, what if we change from a 2 to another number, say 3? Okay, then everything sort of just speeds up, okay, in the sense that each step to the right, you'd be tripling the y value, not just doubling. And so likewise, each step to the left, you'd be taking a third of what you've got. That means on the right, it shoots up quicker, and on the left, it shoots towards 0 quicker as well, even though again, it will never touch 0. The y-intercept is stuck at 1 though, because 3 to the power of 0 is still 1, so changing this number affects the sort of growth rate of the graph and doesn't change the starting point. Okay, and as an aside, this is where such graphs are used most to describe and explore how things grow in nature, whether it's population growth or even man-made things like money in a bank, or even the spread of a virus. Okay, the fact that the graph gets steeper as you go reflects the way that all those things tend to grow or increase faster when there's more of it already there. Again, because we're now thinking about gradients and growth rates and stuff, details will have to wait until we explore these equations properly using calculus. Okay, so finally the usual transformations apply. We'll see a couple of brief examples. If you add 1, then you are controlling the y values directly in this equation, so adding 1 pushes all those y values up by 1. So notice the y-intercept has moved to 2 now. Also the asymptote, the sort of floor that the graph was diving towards on the left, that used to be at y equals 0, it used to be the x-axis. But because we've lifted everything up by 1, the asymptote is of course now at y equals 1 instead. Looking back at the equation, if we change the x to a negative x, that's going to flip things. But it flips things across the horizontal direction because it's the x being flipped, meaning that this sort of flip happens. Okay, the rest we'll leave for you to explore, so that's all for now. Thanks for watching, see you next time.